feet part and then the inches part. So I say int feet followed by float inches. Well, if it should be int or float, it is actually left to you. But in fact, feet has to be integer. Float can be of type. I mean, inch can be of type float. So there are three important variables I declare: dist1, dist2, and then sum. So this is the first value of distance, as in this case, 3 feet 4 inches. Dist2 consists of value 5 feet 6 inches, and then sum is supposed to get me the value 8 feet 10 inches. Okay. Now how it is done using structures. First of all, I want to read the value of first distance. So enter the value of feet. Now just look at how the data is read. Ampersand dist1 dot feet. Then enter inches. Ampersand dist1 dot inch. So these two printf statements will be helping me to read the value of the first data, that is 3 feet 4 inches. Then enter the value of second distance. I read the value of feet. Ampersand dist2 dot feet. And then dist2 dot inches, and then the actual logic starts. So first of all, I must be able to add up the values of feet, right? So I'm going to say sum dot feet is equal to dist1 dot feet plus dist2 dot feet. That means 4 plus 6 I want to do, and hence I must be able to access those two values, and hence dist1 dot feet plus dist2 dot feet. Once this addition is done, it must be assigned to sum dot feet. That is very crucial. The same thing is true with respect to inches also. So I'm going to add dist1 dot inch plus dist2 dot inch, and it gets assigned to sum dot inch as shown here. So far so good, but we have a problem. The problem is, let's look at the second example. If the first value or any value is something like 3 feet 11 inches and second value is 5 feet 6 inches. Now 11 plus 6 is going to be 17 inches. But we know, I mean, we don't have anything like 17 inches. It just has to be converted in terms of feet as well. So I just have to subtract 12 from this value if this sum is more than 12 or equal to 12. So 11 plus 6 is going to be 17 inches. So 17 minus 12 is what I'm going to do. So I'm going to get 5 inches now here. So there will be one carry over here, carry forward. So, yes, sir?
No, sir. So sorry to interrupt. There is some problem with the issue with the slides. Okay. We are unable to see it.
1 minute, sir.
Not visible.
No, sir.
Now, sir?
Screen. So I just.
Yes, sir. Now it is visible, sir.
Okay. Yes.
In the middle. Yes, sir. Yes, sir. No, sir. Yes, sir.
Okay. So the problem is with respect to this set of data. Hello?
Yes, sir.
Yeah. Is it visible, sir? Hello?
Sir,
yes, sir.
Okay.
Yes, sir. Perfectly.
So I was talking to you about this set of data where we have 11 inches and 6 inches in these two values. So 11 plus 6 is going to be 17 inches, but 17 inches implies 1 feet 5 inches, right? So I just have to subtract 12 from this sum. So 17 inches minus 12 inches is what I'm going to do. So that gets me 5 inches. And then there is going to be one carry forward here. So 3 plus 5 is going to be 8. 8 plus 1 is going to be 9 feet. So how to take care of this? So that is why I just have put a simple if statement. So if sum dot inch is greater than 12, or in fact if it is equal to 12 also, I should have included equal to sign here also. So in that case, the value of sum dot feet must be incremented by 1, and then sum dot inch must be equal to sum dot inch minus 12. At the end, I display the sum of distances as sum dot feet and sum dot inch. So let us very quickly move on to a simple exercise and try to see how this can be done. I've tried to have the same program here. I have taken the dev C++ compiler for the purpose of compiling and showing you the output. So the program is exactly the same. I read the first distance and then I read the second distance, and I try to add both of them up, and I check if the value of inch is greater than or equal to 12. and then I take appropriate action. So at the end, I display the output. Now let's try to compile this and then run the program. So as I told you, if the first distance is 3 feet, let's say 4 inches, and if the second one is 5 feet and then let's say 6 inches, the output is 8 feet 10 inches as expected, right? So this is how we can actually get the output. Now let me also try to run it and then show it once again for this special case. Let's say 3 feet 11 inches, and then let's say 5 feet 6 inches. So obviously the answer is 9 feet 5 inches. So 11 plus 6 is what I do. That gets me 17. But 17 inches does not exist. So I just have to subtract 12 from this value and increment the value of feet. Hence the output is 9 feet 5 inches. So this is how we actually look at it. So there are different set of operations possible with respect to structures. Now let's move on and then understand the way in which both of them are connected. That means the pointers and structures. Hope this concept is clear. Now, before we move on, let's try to understand one more important aspect: structures within structures. So I have taken an example of a complex number here. A complex number consists of real value and imaginary value. And let me assume that imaginary value is of type integer and real value is of type float. In fact, you can have both of them as of same type or a different type. I can have float imaginary value, int real value. It just depends on what you want to do. And then I try to have struct complex as a member of one more structure itself as struct number. So I can try to have a variable whose name is comp corresponding to type struct complex. And then I'm going to have int real and declare the variables, so on and so forth. Now this kind of structure, they are called nested structures. So for the purpose of accessing imaginary value or real value, I'm going to say num2.comp.imaginary value. Look at this. I have 2 levels to go, not just one, because it's an example of structure within a structure. So I should say num2.comp.imaginary value. For the purpose of accessing real value, I must say num2.comp.real value and do whatever kind of operation you want to do here. This is how it's basically indicated. Now, if I must make use of pointers to structures, I'm going to say struct number star ptr. And this is just very simple, like what we have been saying so far. So the way in which I read this declaration is start from right hand side. So ptr is a pointer to struct number. That's all. I repeat, ptr is a pointer of type struct number, or ptr points to struct number variable. So the point is, structures and pointers are also very tightly coupled because you can try to do amazing things with respect to pointers pointing to structures. Now, if you want to access the data like imaginary or real corresponding to this struct number, then now you cannot have ptr dot imaginary or real, whatever. You must now say ptr arrow imaginary or ptr arrow real. In fact, there are some shorthand methods of using star operator also, but let me just talk about this operator called arrow operator. Please note, you don't have to search for any extra key corresponding to this arrow operator because you won't find one. It's a sequence of 2 characters, hyphen or minus, and then greater than. So this combinedly is called the arrow operator. So when do I use an arrow operator? Very simple. I use an arrow operator whenever I'm making use of a pointer to a structure. I use an arrow operator whenever I make use of a pointer to structure and whenever I want to access its data. Now, let's say if I don't make use of this statement, if this statement is not there, and if I just declare a variable of type struct number, then I'm going to say, let's say if the struct number variable is x dot imaginary, x dot real, I would say. Is it clear? x dot imaginary and x dot real. Now, since I have had a star ptr here, I'm going to say ptr arrow imaginary or ptr arrow real. So it is very simple to understand. I make use of dot operator whenever I have a structure variable. Whenever I have a structure variable, I make use of arrow operator whenever I have a pointer to a structure. Whenever I have a pointer to a structure. Let us try to see this with the help of a simple example and then understand it. Now, in this case, I want to monitor the age of a person and weight of a person. So age is of type int and weight is of type float, and hence I have struct or structure. So what I do is, inside of main function, I have this declaration. Please try to observe this very carefully. Struct person star ptr, comma person1. So obviously you understand that ptr is a pointer of type struct person, right? Okay. And then what about person1? Is person1 pointer or not? Answers in the chat box. Yes? Is it a pointer? Yes or no? Person1? Yes, Dhanama says it is not. It is not, for the simple reason that there is no any star symbol I have put here. So the point is, PTR is a pointer to structure. Person1 is simple structure variable. So now, just like what we had done in the previous case, I must initialize a pointer variable. So I should say PTR is equal to ampersand person1. And then I'm going to use the printf statement for the purpose of reading enter an integer. That means enter the age. So I'm going to say ampersand star ptr dot age. Ampersand star ptr dot age. The same thing is true. I just ask you for your weight, so I should say ampersand star ptr dot weight. Now please be very careful about this star ptr getting enclosed inside of brackets. And then at the end of it, I want to display the contents back on the screen. So I'm going to say printf %d %f star ptr dot age and star ptr dot weight. This is quite obvious because now you don't need any ampersand operator for the purpose of displaying. Okay, so this is how I'm just going to make use of pointers to structures. Let us very quickly move on to the simulation. Then let's try to understand how this kind of program behaves. The same program, I have copied it here. Now it's time for us to run it. Okay, enter the age and weight of a person, it says. So let's say age is 22 and the weight is, let's say, 60 kgs. So it says displaying the age and weight. Age is 22 and the weight is 60, as simple as this. So you must be able to understand the significance of ampersand operator and putting star ptr inside of brackets. And for the purpose of displaying, you must say star ptr in bracket and then dot age. Okay. So this is very, very crucial. This is how a pointer can be made to point to a structure variable. Now, there is one more important thing you must understand, and that is with respect to the equivalence. Equivalence between star ptr dot age and ptr arrow age. So you can make use of any one of them. So star ptr dot age is same as ptr arrow age. So you should not be confused, saying like just a few minutes ago I told you that I cannot make use of a dot operator whenever I am using a pointer to a structure. Well, I still stand by my statement, but the point is, if you enclose star ptr inside of brackets, this actually gets you to the memory location where ptr is pointing to, and then we say that location dot age. So this is the real age, or this is the real value or the real data I'm actually trying to access. This is exactly the same as writing ptr arrow age. Now, it's quite possible for us to pass structures to functions. In this case, let's look at an example. So I'm trying to model the data corresponding to some student. Let's say the name, character 50, and then int roll number. This is called structure declaration. And then I want to do the display of data through a function, let's say display. It's called function prototype here. And please note the input parameter to this structure is struct student stu. I start with main function. Now I need a structure variable, so I'm going to say struct student stud. I'm going to ask for student's name, so I say %s, scanf %s, ampersand student dot name, and enter the roll number %d because roll number is of type integer, ampersand student dot roll number, and then I simply call the function. Just observe the way in which I call the function. I say display followed by stud. So this is an example where I'm trying to pass structure to function itself, and then I simply return. Now, inside the function, look at this. I say void display struct student stu, and I simply have printf statement because I just have to echo the contents back to the screen. So output name is equal to %s student dot name or stu dot name, and then roll number is equal to stu dot roll number. As simple as this. So what is very important for you is to understand that you can pass structure variables as parameters to functions, like the one I have shown here. Okay. In fact, it's also possible for you to pass pointer to structure to functions. Let us see some example and then understand these concepts. Do we have any doubts? Okay, no doubts. So then I'm going to go over and then try to do the same thing once again. The same program is copied here. So we have struct student followed by the name of student and then roll number. In fact, I know that a student can have many more other features when compared to just having two, name and roll number. They can have USN also, the marks in different subjects, in different internal assessments. Then they can also have CGPA, SGPA, phone number, address, branch or department, and so on and so forth. So all of them can be incorporated. So now what I have done is I have written the function prototype here, and then in the main function I make use of a variable called stud, and then I read the name of student and then read the roll number, and then call the function called student, display the student's information. Then inside the function the same old statements exist. So let's try to see how this can actually run for us. Let's say enter the student's name. I'm going to say ABCD, and then the roll number is, let's say, 11. I hit enter, and the output is name of the student is ABCD and roll number is 11. So this is getting through a function. I repeat, this output is getting printed through a function which I have been able to write here. Okay, so the important point to observe here is that this is the way in which you can pass a structure variable as input parameter to a function. In fact, I still remember one of the companies actually had asked our students with something like this. They had given the structure declaration completely, and they did not give anything inside of main function. So they wrote int main and then followed by some dots, some free space here, and then they actually had given the structure, the function's name, and this thing was supposed to be filled up, and the contents of function was also supposed to be filled up. So the intention was that they wanted students to write the syntax for passing a structure variable as input argument. I repeat, passing a structure variable as input argument to a function like this. So that was a kind of question which was asked to our students. Okay, so do we have any doubts? Okay, now if there is no any doubt, then let's try to move on. As I told you, this is the way in which you can pass structures to functions. In fact, it's also possible for us to pass a pointer to structure to a function. Okay, let me very quickly illustrate this concept to you, and then I think we'll be able to go further. I just want to make a little modification here. Just try to observe it. Now, the structure declaration remains same. Now, I read the values of student's name and roll number from in the main function. Now here, you will agree with me if I say that I'm just trying to pass a structure variable, right? the structure variable is stud, correct? I just have to pass it. But now I just want to illustrate the way in which you can pass a pointer to a structure. I repeat, I should pass a pointer to a structure. So obviously, what should I do now? I should actually declare a pointer, right? So I'm just going to modify the declaration part of here. So I'm going to say star PTR. Is that okay? Now, star PTR is an uninitialized pointer, and I must initialize it before I can use it. So I'm going to say PTR is equal to. Okay, how do I initialize the structure variable to a pointer? Answers in the chat box. Now I must make PTR point to stud. How do I do this? Answers? Is it clear? So how do I initialize pointer so that it starts pointing to the variable stud? Students? Okay, PTR is equal to ampersand stud. Is that okay? So now PTR is now made to point to student. Now I'm just asking for student's name. So I just say ampersand student stud dot name and then stud dot roll number. In fact, if I write PTR here instead of stud, then you know what to do. Ampersand bracket star PTR bracket close dot name, right? So that kind of convention also you can use. Okay. Now here I must illustrate the concept of passing a pointer to a structure, to a function, right? So I'm going to say display ampersand stud. Is that okay? Display ampersand stud. So now look at this. This should change, right? Struct student, I must say star stu. Why? Because the address is being passed here, and hence I must be able to manipulate its content. So printf output name is percentage yes. How do I write this statement now? Can somebody help me? How do I write this statement? Yes. Answers in the chat box. Hello, am I live? Are you able to see the screen? Listen to me.
Yes, sir.
Okay, thank you, sir. Is there any answer for this question, like how do I display the contents on the screen? Yes? Hello? Okay, I'll do one thing. I have just completed this only to 50%, this modification. In fact, I should also have modified here. So I have completed this only to 50%. Now I want you to modify a little bit of content inside of a display function so that you're able to display the contents of the student's name and roll number. Is that okay? Okay, please try this out. And then, as I told you, it's possible for us to pass the pointers to structure to different functions. Now, let us quickly go through some important declarations here. Let's try to understand them, read them, so that we get our concepts right. Okay, can someone tell me what is the meaning of first statement? How do I read this? Minus minus PTR underscore dog arrow age. Any answer? Minus minus PTR underscore dog arrow age. What this could mean? Yes? I'm just trying to type it in the chat box once again. Minus minus PTR underscore dog arrow age. What is the meaning of the statement? Any answers? Yes? I know this complete program is not given to you, but still, given the statement, what do you imply? What do you mean by minus minus PTR underscore dog arrow age? Do we have any answers? Hello? Okay, what could be? I am just getting a doubt if I'm alive or not. Do you listen to me? Can you hear me?
Yes, sir. Screen is not visible, sir.
Yeah. Now, sir. Now is it visible, sir?
Yeah. Zoom.
Okay.
Zoom it, sir.
Okay. Yeah.
Yeah.
So,
Visible.
yeah. Can somebody tell me what is the meaning of minus minus PTR underscore dog arrow age? Very simple. You'll just look at it. When I have arrow operator, the left hand side of this must be corresponding to a pointer variable, right? It should be a pointer. So the name of pointer is PTR underscore dog. It means probably I'm trying to have a pointer called PTR underscore dog to a structure which must consist of, let's say, the name for dog, or the type of a dog, or maybe the age or color of the dog, so on and so forth. So corresponding to a particular dog's age, I'm just trying to decrement it. Similarly, let's try to understand these statements. Struct dog my underscore dog is equal to tiger, bulldog, phi, and white. So obviously this means the name of dog, the type of dog or the breed, the age, and then the color. So if I say something like struct dog star PTR underscore dog, as I told you, PTR dog is a pointer to a structure called struct dog. What is struct dog? Struct dog is a structure which has a data corresponding to different types of dogs. Okay. Now, if I say PTR underscore dog, this is equal to ampersand my underscore dog. That means this particular PTR is now getting initialized to a memory which holds these values corresponding to my underscore dog. And hence, I'm basically trying to say something like J is equal to ampersand I, like what I used to do in the context of ints or floats or characters. So this is the meaning of these statements. Then we have strcpy, string copy, book1.title, pointers in C. What's the meaning of this? Very simple. I have a structure called book1. So the book has a title, right? So for the purpose of accessing title, I say book1.title. What should be the title of the book? Let's say pointers in C. So I just cannot assign it like, okay, book1.title is equal to pointers in C, because that's not allowed in C language. So I must make use of the string copy function from the library that we had discussed in the last class. So I must say string copy book1.title pointers in C. So what this does is it tries to copy pointers in C, this particular string, into book1 structure's title field. I repeat, book1 structures title field or title data. So pointers in C is copied to title. So this is the meaning of this statement. Is it clear? So do we have any quick questions? Okay, Snehal says something. Precedence of operator, we need to check, I think. Well, you don't have to worry about the precedence of operators, Snehal. It is because the moment I say something like this, it always implies a pointer PTR underscore dog, which actually points to the age of a particular dog. So that's very important. Okay. So if you intend to point to a different dog and its age, then you just have to be very careful about putting appropriate brackets here. Okay. Otherwise, you need not worry about the precedence of operators. Okay. One of the important questions about this, and then we'll quickly move to the last topic. So can somebody try to read this for me? Struct emp star dis underscore details struct emp star p. Please focus on the first statement. And can you just type in your answers in the chat box, like what this means? How do I read this? You have 1 minute time to give your answers. Please read the first statement and understand what it says. Please follow the trick that we had used earlier also. You should start from the right hand side and go all the way up till extreme left. Struct emp star disp underscore details struct emp star p. What can be the possible interpretation of this statement? Yes. Do I have any answers in the chat box? Okay, not yet. So please look at the statement. Yeah. Struct emp star disp underscore details struct emp star p. Are you able to follow the session so far at least? Are you able to follow the session so far? Give me the answers in the chat box so that I can understand that you are at least following some of the things that I'm talking to you. Okay, yeah. Okay, so can someone tell me what is the meaning of first statement? Or let me just try to ask the question in a different way. Okay, can somebody tell me what is the meaning of the argument of this function? What is the meaning of this struct emp star p? What do you say about the argument? You know, some functions take int as argument, some take float or character. And in this case, the argument is, look at this, p is a pointer to struct emp, correct? I repeat once again, p is a pointer to struct emp. So this is the argument to a function. What is the name of function? Disp underscore details. Is it clear? So this can be a little tricky. Please try to understand this. I start reading from right hand side, like what I used to normally do. So I start from right hand side. I encounter a round bracket. It means that most probably I have a function coming up. So from this bracket to this bracket I read, and it says struct emp star p. Now once again I'll start reading from right hand side to left hand side. So p is a pointer of type struct emp. I repeat, p is a pointer of type struct emp. So this is the argument to a function. Now let me try to travel further. If I move further, then there is disp underscore details. This is the function name. So now I'm a little bit clear. Disp underscore details is a function name which takes p, which is a pointer to a struct emp as argument of function. Okay. Now, after I'm cleared about the name of function and the type of argument it takes, let me try to move further. Star, and then we have struct emp. That means this function returns a pointer of type struct emp. That's all. This function returns a pointer of struct emp. Now, let me just try to read it. I'm basically talking about a disp underscore details function. Is that okay? Disp underscore details function, which actually takes one argument only. What is the type of that argument? It's p. P is a pointer of type struct emp. So this argument is taken by function disp underscore details, and the return type of this function is a pointer of type struct emp. I repeat, disp underscore details provides a pointer of type struct emp. That's all. Is that okay? Now, on similar lines, can you try to tell me the meaning of second statement? And please be very careful, because such kind of reading of very complex statements, or they give you the statement and then you are supposed to write the syntax part of it. These can be an integral part of your campus placement questions. So can you tell me the meaning of second statement, students? At least give it a try. Let's see. Give it a try. Any answer we have? Okay, can somebody tell me what is the type of input argument to the function? Oh, very nice. Sangeeta says it. She says P is a pointer of type struct office. Correct. Correct. Nisarg also says it. So P points to struct office. So what is this? This is the argument, correct? This is the argument. And what about the function name in this case? Answers in the chat box. What is the name of function in this case? Or do we have a function in the first place? What is the name of function? Name of function. Yeah. Correct. The name of function is disp underscore data. I repeat, disp underscore data. Okay. Now, if you focus on, yes, correct. Shirin, correct. Yes. Now, if you focus on just this part of it, what it means. Please answer in the chat box. Struct star emp. Now, this right hand part is understood by us. So the input argument is struct office star p. The name of function is disp underscore data. And then we have struct star emp. What is the meaning of this? Amog says it's a function name. Oh, not really, Amog. The function name is this, disp underscore data. So I'm just asking you, like, what is the meaning of this particular statement, like struct star emp? Any answers? Okay, Preeti says it, disp underscore data is returned to pointer to emp. Okay. Sureka says it's return type, and then Amog says structural declaration. Oh, well, structural declaration doesn't appear here, Amog. Structural declaration is done in the very beginning. Okay. Tech engineering, the person says structure is empty. Well, no. Sana says data type, and Kavita says pointer to structure. Oh, well, no. Pointer to structure is not defined in this way or declared in this way, right, Kavita? Now, if you compare with the first statement, there is only one change in position of the star variable. Okay, so instead of saying struct emp star, I have struct star emp. Please note that second declaration is error. Okay, so second declaration is syntax mistake. Now, I just asked this question to you intentionally because every single time you start reading from right hand side, you go through all these statements and stars and then all of them. And when you come here, EMP, I know that EMP is the name of a structure, right? This was used for declaring structure. So If I want to return a pointer, look at the first one. If I want to return a pointer of type struct emp, I must write like this. But if you interchange the position of star and emp, it says struct star emp. Now this pointer should never ever come between struct and emp, and hence this is syntax mistake. Is it clear? So I repeat once again, struct star emp. Now this part actually creates problem, and this is a mistake. The compiler will generate error message. So if you want to return a pointer to a structure, then you must write like the first one, whereas the second statement is completely wrong. Now this is all okay. The name of function is disp_data. The input argument is struct office star p. All of that is correct, but this particular part actually generates error, and hence this is incorrect. Okay, so are there any questions before we move on? Are there any questions before we move on? Okay, well, no. Then let's try to continue and then see a simple quiz. How do you find the size of a struct type? So we said struct emp, correct? So how do you find the size of this struct type? Answers? Okay, the answer is very simple. You make use of size of operator once again. Size of operator, yes. So if you look at the chat box, I'm just giving you the answer. You simply say size of struct emp. If you write like this, you are going to get the size of structure variable. In this case, I'm talking of emp. In the other cases, it can be whatever structure you are talking about. Okay. Then what is the latest version of C language? What is the latest version of C language? Okay, I'll just leave this as an assignment to you. Now, have you heard of C11? C11. Now, that is one version of C language. I'm talking of this version of C language because it actually has a very important modification. And the modification is, I have just given an example here. Now, if I'm talking of some sort of function, it has an input parameter and then it's return type, right? Int is return type. The name is, let's say, function, and it takes only one argument here. Now, inside the body of function, if you want to allocate memory, depending on the value of int n here, that's very much possible. So the C11 version of C language has made this possible. In the earlier cases, in the earlier days, this was treated as error. Why? Because maybe int n is a variable that you are going to pass during running of the program. So if it is so, then how would the compiler allocate sufficient memory beforehand? So that's why this was treated as a mistake or error. It was not allowed, but in C11, this is very much allowed. So that's it for pointers and structures. Now, very quickly, we'll move on to pointers and functions. This is the last topic, and this is going to be once again very, very important. Please try to focus and understand. Very quickly, I'm going to go through, first of all, basics of functions. All of us know that function is a set of repeated instructions. A function can be called any number of times by anybody. You can pass different types of parameters as arguments. You can also have different types of return types from the function. Basically, there are two types of function calls. The first one is called call by value and then call by reference. I hope you know the difference between call by value and call by reference. I just have a simple question for you. Now, if I'm asking you to write a function for swapping two numbers, what would you prefer? Call by value, call by reference? The question is, if I have call by value and call by reference features then for the purpose of swapping two numbers, which one do you prefer? Okay, some people have answered like C18 and C15, C17. Okay, call by reference. The question is why? Why do you prefer call by reference? What is the problem if I go for call by value? It's easy. Oh well. It has, okay. Call by value does not swap numbers. Why? Okay, Sureka says it. Oh, correct. Sunika says we will use address. In call by value, value is transferred to function. Well, Amog, okay, it's not the value which is transferred to a function, but it is a duplicate copy. So let me just illustrate this to you with the help of a simple example. Your answers are right. You know, if I'm asking you to swap two numbers by call by value, this is how it looks like. So we have a void swap followed by int a and int b. Then let me just take a simple example of values being 5 and 6. So before swap, inside main function, a is equal to b is equal to a and b. So obviously you would expect 5 and 6 here, and then you call the function swap. The arguments are a and b. So I go here, and then I created a temporary variable. I have temp is equal to a is equal to b is equal to temp. Now this logic you know. And then inside the function, I'm going to display the values. And then after I come back to the main function, I'm going to display the contents of a and b after swap, right? So if you try to look at the output here, now we have a problem. Now before swap, inside the main function, I have the value of a as 5, b as 6. Perfectly okay, no problem. Now inside the function, a is now equal to 6, b is equal to 5. Once again, perfectly no problem. But after swap inside the main function, I have a is equal to 5, b is equal to 6. So the values haven't really changed. They have not changed because the moment I have call by value, as in this case, call by value, it is not the value which gets passed, as Amog was mentioning. It is actually a duplicate copy of variables a and b which get passed here. So whatever change that happens on the duplicate versions of these variables a and b. Now you can say, look, here we have ab and here also we have ab. Well, that hardly matters. Why? Because this ab is very different when compared to these variables a and b. They are physically distinct memory locations. Okay, they are physically distinct memory locations. So whatever change that happens on the duplicate variables will never be reflected on the main variables. So that is why call by value, that is this problem, this particular point has a problem. So we don't prefer going for it. So what we do is we prefer going for call by reference. We go for call by reference, and let me just try to very quickly illustrate that concept to you. Once we feel comfortable with functions, let's go with pointers and functions. Here, I have shown you the modified code where I say not swap AB, but I say swap ampersand A ampersand B. Okay, swap ampersand A ampersand B. And then inside the swap function, I say int star A, int star B. And the same logic continues. I create a temporary variable and I say temp is equal to star A. Star A means it is content of A. I don't simply say temp is equal to A, because if you say temp is equal to A, equality sign has left hand side as integer variable, right hand side would be a pointer variable, so there will be incompatibility. So that's why we should say temp is equal to star A or content of A. Content of A is equal to content of B, and content of B is equal to temp, and then you print it. So in this case, look at it. In this case, what happens is initially at point X, where is point X? Inside the main function before swap. The values are 5 and 6, and then Y point. Here we have after swap inside the function we have 6 and 5. The swapping has indeed taken place, and when you come back inside the main function at point Z, you display the values of A and B. Now they are properly swapped. So swapping of such variables requires you to act on the original memory locations, and hence you must always call by reference. Then let's try to understand the concept of function pointers. Okay. Now I want you to be very careful here, absolutely focused, because this can be a little tricky. This can be a little difficult to understand. But once you understand the syntax part of it and the logic behind function pointers, it's very simple and straightforward. Now, earlier, when Professor Kotresh and Professor Srikanth were mentioning about different data types and different pointers and the way of initializing them and dereferencing them, or so on and so forth, then we had a simple example like, okay, int star j, and then j was a pointer variable, right? Pointer variable. And then I used to initialize j with the address of some data. Let's say j is equal to ampersand I. That's what I used to say. That means I pointed a function, pointed to a data in the previous cases. I repeat, I made a pointer point to data. But now I'm trying to make a pointer point to a function, not to a data. So I'm making a pointer point to a function. What does that mean now? It means I'm trying to treat program as if it is data. Does it make any sense? Well, yes, it makes sense. Why? Because from your previous semesters, you must have studied that the entire memory can be, consisting of data part or data segment, program part or program segment, and stack segment, and so on and so forth. So when I write a function for doing any functionality, for any action, for example, swapping of two numbers or finding the array of n numbers, or finding factorial or whatever. So when I write a function must occupy some space in memory, right? So it must have a starting address. If the size of a function is, let's say, 1 kilobytes, 1 KB, then if I assume that the starting address is 1000, so starting from 1000 till 2024, to be precise, 2023, the function will exist. Why? Because I assumed that the size of function is 1 KB. So it's very important for us to realize that a function also has a starting address. Now we make use of this fact and we make a pointer point to a function. As usual, a pointer does not point to complete 1 KB of segment. No, a pointer just has the starting address of a function. That's very, very crucial. Okay, so a function pointer is a pointer which points to the starting of a function. I repeat, a function pointer is a pointer which points to the starting address of a function. Now, I don't want you to confuse this with a function which returns a pointer. Okay, just to make the concept clear, let me just illustrate this with the help of an example. If you look at first statement, I start reading from right hand side. So I encounter a round bracket or parenthesis. So it means that I must have a function name, right? Okay. Inside these parentheses, I have two keywords, int, int written here. It means that I must have a function name which tries to look at two values as input arguments. Okay. When I come to the left hand side, I have compare. So obviously this must be the name of function. Okay, so compare is a function which takes two integer arguments, and what is its return type? Bool star. Bool comprises of, it means Boolean value. So star implies it's a pointer to a Boolean variable or Boolean value. Now let me read this completely. Compare is a function which takes two integer arguments and returns a pointer of type bool. Well, this is not the concept of function pointer. I repeat, the first statement is not the concept of function pointer. I told you one thing. A function is returning a pointer to something else here. Correct? A function compare is returning a pointer to some type of data variable. This is not a function pointer. Function pointer means a pointer which points to the starting address of function. How do I indicate it? Its syntax is as follows. Okay, let me start reading from right hand side. I encounter these two brackets, and then it must mean that there is a function. So the arguments are int comma int. So now I understand that I must have a function which accepts two input arguments of type integer. Now when I come here, look at this. Amazingly, I'm trying to travel from right to left. Amazingly, I find this one more pair of brackets. Okay, so when I encounter the first pair of brackets, I thought that whatever that comes in here should be the name of function, right? But in this case, I'm trying to find one more pair of brackets. It means that compare is not the function name. No, it's not a function name. It is a pointer. How do I say this? Because star is written here and both of them are enclosed together. Both of them are bundled together, combined together. So now I understand that compare is a function pointer. Okay, so star compare being written like this means a function pointer, and star compare without any brackets written like this means compare is a function name. It returns a bool star as return type. So be very careful. Compare is not the name of function. It is a pointer in this case, in the second case. This is a function pointer which will point to any function. That is crucial. That's crucial. So compare is going to point to any function which can take two input arguments and which can have bool as return type. I repeat, compare is not the function name. It's a pointer name which can point to any function. Which function? What is the name of function? I still don't know. Okay, so compare is a function pointer now which can point to any function which can take two input arguments and return bool. So this is the syntax of a function pointer. First one is not the syntax of function pointer. In fact, this is not at all a function pointer. It is a function which returns a pointer. But in this case, compare is a pointer which stores the starting address of some function. Okay, so this is very important. Let us try to understand with the help of a simple example. The syntax is as follows. First of all, we have hash includes, and then I have a function written here. What does this function do? It just displays the message value of a is. What is a? A is the input argument. Okay, so there is nothing extraordinary about this function called fun. Now the trick lies in the main function. Now let me see what happens here. I say void star fun underscore ptr of int. Well, if I start reading from right hand side, I have a bracket, so it means that I expect a function name here which can actually take integer as only one input parameter or argument. But after this round bracket, I have one more pair of round brackets here. It means that this is not the function name, but this must be a function pointer, right? So this function pointer can point to any function which can take integer value as argument and return nothing. So if there is such function, then this pointer can point to that function. So this is called declaration part of it, but I must initialize it, right? So I need some function actually. So I already have a function whose name is fun. So I'm going to say ampersand fun, that's all. So this statement is declaration of function pointer and initialization of function pointer. So when I say like this fun underscore ptr is now pointing to the starting address of this function. That is the meaning. Now, how do I call this? I call the particular function by making use of syntax bracket star fun underscore ptr bracket close followed by some number. So when I invoke the function like this, the function ptr, which actually points to fun function, calls this function. This gets executed and I come back and terminate. Well, let's try to understand how it actually works with the help of a simple example. So I have just copied and pasted the program here. Let me just try to run it So if you look at the definitions, they are still the same, like whatever I have shown there. So I have declared a function pointer. I have initialized it with the starting address of fun function, and here I have invoked it using the function pointer. Let's try to compile it and run it and see how it behaves. It says value of a is equal to 10. That's all. Value of a is equal to 10. There is nothing extraordinary about this. So it just means that fun PTR took a static variable 10, and then this function was called. The function displayed the value. Well, don't you think that this is quite not so useful? This is not useful. Why? Because I need not actually pass a constant value all the time. So what I do is I'm just going to ask the user to enter a value and then show it to you. So what I do is I say int I and then say simple printf statement, enter a data, and then I'm going to make use of the scanf statement, and I'm going to read the value. Let us say ampersand I, correct? Then what I do is I just pass this I value so that whatever I enter gets displayed on the screen. That is very crucial. Is that okay? Okay, let's try to compile this and run it. Okay, it says enter data. I'm going to press 21. I hit enter. It says value of a is 21. Very simple. So this is much more interactive when compared to what I had in the previous case. So the point is, you can pass any variable value to a function which gets pointed to by function PTR. That's very important. Now, please understand, if I declare function pointer like this, this function pointer cannot point to any other function which has two input arguments. Let's say int x and int y. No, I simply cannot do that. Why? Because I have declared this function pointer in this particular way, and in the declaration part I just mentioned only one int, right? So this function pointer can point to any function which can take up only one input argument. Only one input argument, and that's very, very crucial. Is that okay? Do we have any questions? Okay, there are no any questions further. Now, if that's the case, let me go further. This particular line and calling of this function is also equivalent to writing something like void star fun underscore PTR int. Now, this is called function pointer declaration, and then later on the next line I can write it like fun underscore PTR is equal to ampersand fun. So this is called declaration and initialization, but this is called declaration part and this is called initialization. So you can go for any one of them, whichever is comfortable for you. There are some interesting facts about the function pointers that you must understand. The function pointers, as I told you, they point to code, they point to programs and not to data. And they store the start of the executable code or the starting address of the program. And we should not allocate or deallocate memory using function pointers. Usually memory allocation and deallocation is meant only for data, using I think malloc function and calloc function, realloc function and free function. But don't use that technique for function pointers. Next, a function's name can also be used to get function's address. This is very, very important. Just like what I do in the case of an array. I can either say ampersand ARR or I can just say ARR, right? An array's name itself gives me the starting address of the array. Just like that, a function's name itself can give me its address. I need not say ampersand fun. I can just say fun. It gives me the starting address. And we can also have an array of function pointers. Now, this is very crucial. An array of function pointers means I have n number of pointers which can point to different types of functions altogether. Interestingly, it can also be used in the place of switch case statement. Let us try to illustrate this concept with the help of an example. A function's name is itself its address, as I told you. Just try to compare the previous statement with this statement. In the previous statement, we had ampersand fun, but now I have removed it. It means just by mentioning the name of function, I can still get the address of the function. So that I'm trying to assign it to fun underscore ptr. And then I say fun underscore ptr of 10. Here also I have removed star symbol. So the moral of story is very simple. If you put ampersand symbol here, then you should say star symbol here. If there is no ampersand here, don't put star symbol here. So this is the way in which you declare, initialize, and call different functions using function pointers. Let us try to see an example of how I can make use of a function pointer to act as if it's a switch case statement. Now this is an example where I have some 3 or 4 functions written here. The first function is called add. Obviously it's quite self-explanatory. I pass 2 variables a and b. You just have to get me the sum. So I say printf addition is equal to %d, a plus b. Similarly, I want to subtract these 2 numbers. So the answer is a minus b here. And then I want to multiply 2 numbers. So multiplication is equal to a star b. So these are 3 functions. Along with this, we have the main function written here. Now, please focus here once again. Look at the red colored statement. Let me once again try to understand it. Okay. Okay. If you start from here, there is a pair of brackets. So it means that there must be some function name here. So I have int comma int. So I expect 2 input arguments of type integer. When I come here, amazingly, I have once again this bracket and this particular bracket. It means that this is not a function name because there is star fun ptr array. So the way in which I read it is once again start reading from right hand side. I encounter square bracket here. So it means that it must be an array, correct? It must be an array. So if I move towards left, the array name is fun underscore ptr underscore arr array. Fun underscore ptr underscore arr, and this is also followed by a star symbol. So whatever that appears in these 2 brackets, I must read it in a single go. So now I understand it. This corresponds to an array of function pointers. An array of function pointers. What does that mean now? It means this array of function pointers can point to any function which can actually take 2 input arguments of type integer. What about its return type? Nothing. It's void. So now I'm going to initialize it to add, that is add, subtract, and multiply. Now please note these 3 are the names of functions like what I had shown you in the previous slide. So when I do like this, it means that the addresses of add function, subtract function, and multiply function are stored in this array of function pointers. Then what I do is I just have some values of a and b statically initialized, and then I'm going to ask you for a choice. I have declared it as unsigned int. So it says printf enter choice. If you press 0, I'm going to add 2 numbers. If you press 1, subtraction will be done. If you press 2, multiplication of these 2 numbers will be done. So I read the value of choice from your end. Now it's quite possible for you to press let's say option 3. Option 3 does not exist. Number 3 does not exist. So in that case, if the value of ch is greater than 2, I simply return. I don't do anything at all. I don't even bother to display an error message. I simply quit. I just return. Let's say if you press 0, then this is not greater than 2, right? I just go to the next statement. Now this is the call to a particular function depending on which choice you enter at the command prompt. Now in this case, if I press 0, the value of ch is 0. So star function pointer array of 0 and a comma b are passed. The value of a and b are 15 and 10. That's correct. But in this case, function pointer array ch equal to 0 is passed, and hence I'm going to add both the numbers. I add both the numbers, and the function, going back to the previous slide, is going to just get me the value of a plus b, and it returns nothing. Now, if I press ch as 1, then function pointer array, from this particular array of function pointers, I'm going to execute the second function, which is meant for subtracting two numbers. The same thing is true for multiplication of the numbers. So let me just try to very quickly illustrate the concept to you. Okay, we have a couple of questions here. Just a minute. Okay, not the questions, but sir is trying to comment on some of the things. Yeah, void star function pointer int. In this, function pointer is a function whose return type is void. Correct? Yes, very much, very much. So let me just quickly go to the function pointer program. I just try to copy it down and then paste it in dev C++ text editor. So you can see here that we have hash include, and then there is a void add, and so on and so forth. So this is the add function, and then we have subtract function, followed by a multiply function, and the main function. In the main function, as I told you, we have star fun ptr array, and then this declaration and initialization is done. And then I have declared the other variables. I ask you for a choice, and then if there is invalid choice, I simply quit. Otherwise, I call the appropriate function through the function pointer. Let's try to compile this and then run. Let's see the output. Okay, it says enter the choice. Now, if I press 0, please remember the value of A is 15 and B is 10. That's what I have put in my program. So if I just hit enter, I'm going for add function. So 15 plus 10 is going to be 25. As simple as this. On the other hand, if I go for, let's say, option number 1, and if I press enter, it gets me the subtraction. Okay. So once again, let me just try to illustrate the third option as well. Let's try to go with the multiplication of two numbers. So 15 times 10 is going to be 150. Very simple and straightforward. Now let me just try to give some kind of other input. Let's say I'm just going to press 6, which does not exist. So there is no any function pointer with value of index as 6 for the purpose of pointing to a function which can actually do something for us. This is wrong thing to do. I simply press enter, and there is no any kind of output that appears, because the value of ch is now greater than 2. The value of ch is greater than 2, and hence I simply return. So this is how I can make use of function pointer. So if you look at it, what actually is happening is this function pointer array is actually helping me to behave like a switch case statement. In switch case statement also, depending on what kind of input value you choose, you are going to go to that particular case statement and then perform whatever operations you want to perform. So this is the power of function pointer, which you can use for implementing any other functionality. Let us try to very quickly go through some simple declarations, and then almost we come to the end of the presentation. Let's say int bracket star f bracket close and int comma float. It's very simple. I just use the same technique. There is nothing like any extraordinary technique for very complex declaration. No, I start from right hand side. I encounter this bracket. It means that there must be a function name. So this function takes one integer argument and one float argument. When I come here, I expect a function name, but the function name doesn't exist. I have one more round bracket here, followed by its corresponding bracket. So whatever that appears inside must be read in a single go. Now, what I have inside is star f. Star f. So now I understand. Star f is basically a pointer, function pointer, which can point to any function with int and float as input argument, but that function must give me int as return type. If that function gives me void, then I cannot make this f pointer point to a particular function. So this is very crucial. So I read this as a pointer to a function that takes an integer argument and a float argument, and returns an integer as the output of function. Next, int star g int comma float. Well, look at this. They are quite different, very, very different. Very different because there is no bracket here. So it means I start from right hand side. So we have brackets. So it means that this is a list of arguments. This must be the function name. Look at this. It's a function name basically. Why? Because I don't have any pair of brackets around star and g. So now I understand. G is a function. It's a function name which has two input arguments. One is integer, other is float. And it returns a pointer to integer as output. It returns a pointer to integer. So this is not a function pointer. This is a function pointer. Going the same argument, let us try to understand the meaning of a third statement. I start from right hand side. So I encounter this round bracket. So it means it must be the list of arguments we have. There are two arguments. The first is int and then we have float. And then I expect the function name to be here. But here, unfortunately, there is one pair of parentheses. So whatever that exists here inside of it, I must read it in a single go. Now, if I once again start from right hand side, there is a square bracket here. It means that there must be an array. Then there is g and then there is star. So this basically means an array of function pointers, an array of function pointers. Okay. So this array of function pointers is going to point to any and every function which has integer and float as input arguments and return a pointer to integer as output. So in totality, I'm going to read it as an array of pointers to functions or an array of function pointers, and each function takes an integer argument and a float argument and returns a pointer to an integer. So this is how we understand very complex declarations. Okay. Now, I just have a very quick assignment and then almost we're coming to the end of it. I guess this is the last slide. So I want each one of you to answer these questions very carefully because this is a fair mix of functions, pointers, function pointers. So please try to read these statements and then let me know if there is any doubt as such. Okay, let's start the first one. That is this. Void star star foo int star. So can somebody tell me what is the meaning of this statement? Answers in the chat box. Any answers? Yes. What is the meaning of first statement? Void star star foo int star. Okay, now let me break this down. What is the type of argument to the function? Please answer in the chat box. Very nice, Preeti. It's an integer pointer argument, correct. So do we have a function pointer here? Yes or no? Oh, well. Somebody is saying, Pavitra is saying function foo taking no arguments. Well, that's not correct, Pavitra, because the argument here is int star. It is very clearly shown to you here. Okay. So Nisarga says foo is pointer which stores function value int. Okay. Well, I just have to rephrase it. So if you look at it very carefully, int star is a type of argument, correct? Okay. Now, do we have a function pointer? Yes or no? Quickly. Do we have a function pointer here? Priti says yes. Sangeeta says yes. Nehal, Surekha, all they say yes. Why? Because I have this pair of brackets and inside of this there is star foo. Star foo. So star foo, it basically implies a function pointer which can point to any function which takes int star as argument, and that function must be able to give me void star as output. That means it must return a pointer to nothing. Now that's very funny, but still for the purpose of understanding, I repeat it once again. Foo is a function pointer which points to any function with argument int star and returning a pointer to void as the output. That's the meaning of first statement. Okay, now can somebody tell me what's the meaning of second statement? How do I read this? Okay, what is the argument to the second statement? What is the argument list? Argument list is comprising of two data types. The first argument is integer value, and then we have float star value. Okay, now do I have a function pointer here? The answer is yes. Why? Because we have once again this bracket, this bracket, and then there is star my fun. So I would read this now. Please be very careful. My fun is a function pointer. My fun is a function pointer which can point to any function which can take two arguments. What type of arguments? First is integer, second one is float star. And what about the return type of that function? Just integer. Yes, just integer. So Preeti says something. My fun is a function pointer taking two arguments and returns to int type. Very nice, very nice. That's correct, Preeti. Then let's go for a third one. What do you feel about this declaration? Float star, your fun, char star, int star star. Okay, first question. Do we have a function pointer? Yes or no? Do we have a function pointer? Yes or no? Very nice, very nice. You got this concept right. So the point is, very nice. The answer is correct. No. The point is, just by merely putting this pair of bracket does not mean that there is a function pointer. I will have a function pointer if there is a star symbol along with this particular name. So in this case, I start reading from right hand side. So I will have this pair of brackets. So it means that there must be a function name. So the function takes two arguments. The first argument is char star. That means a pointer to character. Second argument is int star star. That means a pointer to a pointer of type int. I repeat once again. First argument is a pointer to character. Second argument is pointer to a pointer to int. That means it's a double pointer. So these are the two arguments taken up by a function whose name is your function or your fun. So in that case, actually these brackets were not needed, but just to test our understanding, I have put them. Now I'm getting more clearer now. Your function is a function which has two input arguments like shown here. And this function returns a pointer of type float. A pointer of type float. Is that clear? That is the understanding of third statement. So obviously there is no function pointer involved here. Okay, now let me look at the last statement. Come sum plus equal to bracket star fp bracket close and then I. What is the meaning of this? First question. Do we have a function pointer? Yes or no? Do we have a function pointer? Very nice, very nice. I'm getting good responses. Okay, so there is a function pointer. Its name is fp, correct? Fp. So how do I read this? If you try to kind of expand this, it will be come sum equal to come sum plus star fp of I. Correct? No? Is that clear? Come sum is equal to come sum plus star fp of I. So we know that this is a shorthand notation for adding these two numbers and assigning it back to them. So come sum is equal to come sum plus star fp of I is the expression. Now please tell me what's going to happen. What is the meaning of this statement? Okay, do I have a function pointer on this line? Yes or no? Do I have a function pointer? Oh, Sangeeta says it. Nisarga also is saying yes. Obviously yes. Why? Because I have it here. Yeah, I have it here. So the point is, through this function pointer, I am trying to call some function whose address I have initialized somewhere else. I'm trying to pass a parameter I, but this function pointer is returning some value. For example, do I know the type of cum-sum? Well, I don't know. Let me assume that it is integer. So if this is integer, then obviously this particular part of whatever I have done here must be able to get me integer as return type. So that value, I'm trying to add it along with the cum-sum, and then the same thing is assigned to the left-hand side variable. So I repeat once again, FP is a function pointer which is pointing to some function which can take one argument I as input and return an integer which will be added up along with cum-sum, and then it gets assigned to cum-sum. So that's the meaning of this particular statement. Is that clear? So the list just goes on. It just goes on and on and on. So in fact, you can have different types of declarations, different purposes of usages of pointers and functions and arrays and so on and so forth. So with this, I'm just going to close down now. If there are any questions, please let me know. I'm just going to wait for 1 or 2 minutes in the chat box, and please tell me if there is any kind of question as such. Now, these questions need not be from just this session. These questions can be from any of the sessions that we have covered so far. Professor Kotesh and Professor Shrikant, they are with me now. They're online. So all the three will be able to answer to your queries. In case if there is no any query, then I think we will continue with the feedback and then the test that we have scheduled. Okay. So we'll just wait for 1 or 2 minutes and see if students have any doubts as such. So do we have any doubts, any questions from whatever we have covered so far? Please feel free to ask the questions, because if you ask the questions, then only you will get the answers, correct? Are there any questions on the basics of C programming, like what Professor Shrikant covered the other day? Or are there any questions from the basics of pointers, like what Professor Kotesh covered the other day? Any questions on pointer arithmetic, pointers and arrays, pointers and strings, pointers and structures, and pointers and functions? Well, this is what we had proposed to Sir, Dr. Ravi Mandali Sir, and Akole Sir and Pramod Sir. So now this is something like this, just to tell you, these are some 6 or 7 points, but each and every point is quite elaborate. I mean, if you just start talking about pointer arithmetic, there can be a very huge set of material, or pointers and arrays and pointers and strings, or pointers and functions or structures. So each and every sub point actually has a lot of syntax and semantical issues. We just have to be very careful about each one of them. Okay. So are there any questions? Yeah, I think Sana is asking on what basis we tell the language is structural programming. Okay. Well, do we have any answers? Professor Shrikant and Kotesh can also join me in answering the questions now.
Yes, sir.
Hello.
Hello, sir. Yes, sir. Yes, sir.
Or did I lose the connection?
No, sir. You are on the line.
I think let me just once again. No? Hello.
Hello, sir. Hold on, sir. Hello,
I
sir.
can hear you. I can hear you very faintly. Hello.
Sir, am I audible, sir?
Hello.
Hello, sir.
Hello, sir.
Yeah. Okay. Yeah.
Hello.
Yes, sir. Now it is. I think there was some network issue as such. So I suppose. Okay. So, hello.
Huh, sir.
Okay. Yeah, please join me in answering the questions also. So we had one question like, what is the basis we tell the language is structured programming? Well, I would say it is very simple and straightforward. If the language gives you some kind of constructs where you can actually, write the program in terms of clearly defined goals. For example, if I start writing a very huge program, for example, let's say, if I ask to design a soda can vending machine, in that case, what happens is there are a couple of operations. First of all, you actually deposit the money. Let's say if the soda can cost you 20 rupees, so you must deposit 20 rupees, and then there must be someone to check for the validity of your input, right? For example, if you just deposit 10 rupees, there should not be any soda can out given to you, right? So the total amount of money that you deposit should be 20. Only then the output operation should occur. And then there should be some function to actually dispense the soda can, give the soda can out back to you. So I recognize that these are a different set of operations possible. And, if you can arrange them appropriately in proper flow and hierarchy and proper structure, then if such a language is available, then you can say that it is an example of a structured language. Okay. Well, whatever we are talking of right now, they're all examples. It can be C or C++ or Java, so on and so forth. So all of them are examples of a structured programming language. In fact, this kind of programming is also called modular programming. This kind of programming is also called modular programming. Okay. So does it answer your question, Sana? Okay. What is the difference between running and execution? Like what, Sana? Can you just be more specific?
If students feel to talk and if they want to ask the doubt instead of, if you feel typing could be difficult, they can talk to us.
Hello, sir.
Yeah, is that Sana?
Hello, sir. Yes, sir, I'm Sana.
Yeah, go on.
Sir, what is the difference between the execution?
Running and execution of a program, you mean?
Hello. We are running the code, we are executing the code. Actually, I'm not
Okay,
getting
according to No, according to what I know, as far as I know, execution is the correct technical word. You execute the program or you execute the code. But when I say run it, I would say it's a very colloquial language that we use. Colloquial implies, in Kannada we say adu bhashe, like whatever we say very casually. So otherwise, technically speaking, I don't think there is any problem or any difference with respect to running and executing the code, Sana.
execution. Means both are same, sir.
Okay. Yeah. Yes. I would say same. Yes. Then we have a question by Sangeeta. Is it possible to divide two pointer variables? Sangeeta, it is not possible. It is not possible because if you were given a chance to divide those two variables, then what's going to happen? Why would you need the division of two pointer variables? That is big doubt we have. So is your intention to assign such a value to another variable or another integer? Well, that does not make any sense. So that is why division of 2 pointers is not okay. It is not allowed. Division of 2 pointers would simply mean that you want to divide 2 addresses. The question is, why do you want to divide 2 addresses? So it is not possible. Please look at the chat box. I'm just going to type something here. You can do something like this. Please observe the chat box, all of you. You can do something like this. Star PTR1 divided by star PTR2. Well, what am I trying to do? I'm trying to divide the contents. Which contents? Content pointed to by PTR1 and content pointed to by PTR2. So that's why I say star PTR1, star PTR2. But I cannot do something like this. Please observe the chat box once again, all of you. I cannot do like this. PTR1 divided by PTR2. Not possible. Because the second statement would mean I'm trying to divide 2 addresses. This is not okay. But star PTR1 divided by star PTR2, it means I'm trying to divide 2 numbers. That's perfectly okay. That's perfectly okay. Okay. So is that okay, Sangeeta? Okay, she already said yes. Yeah. Kotesh also is helping me out. Then there is one more question by Pavitra. Sir, what's the difference between near, far, and huge pointer? Well, this question is relevant in the context of Intel series of processors, because what happens is, okay, Pavitra, just let me ask you a question. Have you gone through the advanced microprocessors 80x86 architecture, Pavitra? You can just unmute your mic and then talk, Pavitra, no problem. Pavitra, am I audible? Hello, am I audible?
Yes, sir. You are audible, sir. Audible,
Okay,
sir.
okay, okay.
Audible,
Yeah.
sir.
So, have you gone through a course? Akole sir can help me. Sir, did they have any course on x86 architecture, sir?
8086 they have undergone,
yes.
sir.
So if you have undergone 8086 architecture, then I think you would understand one important thing. You know, if I have a pointer, for example, how far I'm able to address memory locations using that pointer. So Intel architecture has done this near, far, and huge pointers. It has basically to do with the range of addresses which are covered by a particular type of pointer. Okay. Well, I don't exactly remember what is the range of address for near pointer, far pointer, and huge pointer, but whatever written is right. I mean, near pointer is going to point to, I think, 64 kilobyte address range, if I'm not wrong, 64 KB. Then I guess far pointer is going to get me, I just don't remember, 256 KB or so, and huge pointer is going to get me anywhere and everywhere, that kind of memory access. So that's relevant for Intel architectures. Is that okay, Pavitra? Okay. So if there are no other questions, then shall we, Akole sir, shall we start with the evaluation process? A very quick small test. Quiz, sir?
Yes, sir. Yes,
Okay,
sir. Go ahead, sir.
We'll have a quiz now. That will be coordinated by Professor Srikanth and Professor Kotre, sir. And after that, we'll have a very quick feedback session, and then we'll wind up. Okay. Thank you so much.
Sir, some students are giving feedback.
Okay, okay, sure, sir.
Then I will conclude.
Okay, sure, sir. Okay. Kotesh and Srikanth, shall we start with the quiz?
Yes, sir.
Yes, sir.
I already shared the link in
Oh, great.
the chat
Okay.
box. Students can click on the link, and I will be, right now the time is 12:45 in my watch. I will be giving the 30 minutes time for them, sir.
Okay, sure.
Same is posted in WhatsApp group.
What's posted in WhatsApp group also?
Yes, sir.
Oh, yes.
Yes,
I have.
yes, sir.
Okay. So after 1:15, you will not accept any responses?
Yes, sir.
Is that what it means?
Yes, sir. Yes, sir.
Okay.
The link will be enabled till 1:15.
Students, please note.
The link will be enabled till 1:15.
So I request all the students to click the link up to 115 and give the quiz answers. Correct, no, sir?
Yes, sir.
Oh. Now, sir, how much time it will take quiz?
Sir, 25 to 30 minutes, sir. 30 minutes.
Now, what to do, sir, within that period?
Um,
Some students are interested to give the feedback.
Sir, let them give, sir. Then we can. Navalgund, sir?
Yes, yes, Shrikant.
Sir, anyways, like 115 is 35 minutes from now. If some students wants to give feedback,
sure.
they can give, sir. They can give. We can extend for 5 more minutes.
Oh,
The
sure, sure. No
students
problem.
who finish quiz
Or
early,
let them finish. Or let
they
them
can
finish.
join for the feedback.
Sir, or let them finish.
Yes, sir. As soon as they finish, or else some students are asking whether to leave the meeting or what. So in that case, let them give the feedback and then they can go ahead with the quiz.
Sangeeta, wait.
Yes.
Sangeeta. Sangeeta, don't leave. All of you don't leave. Log out. Still wait for some time. We will finish and then we can log out. Sangeeta. Shall I start, sir?
Yes, sir.
So please, sir.
Okay. Sunita. Hello, Sunita.
Yes, sir. Yes, sir.
Can you give feedback now?
Yes, sir. I will.
Okay.
Good afternoon from 8.
You are not audible, Sunita. Sunita.
Now, sir?
Yeah.
Yes, sir. Now, sir?
Yeah, please go ahead.
Sir. It's my pleasure to share few words about workshop sessions. I will thank our HOD sir, Dr. Yadali sir, for organizing this wonderful workshop for us. Thank you, sir. I thanks to Dr. Navalgund sir, Professor Kotre sir, and Professor Shrikant sir, sharing their knowledge with proper guidance and perfect explanation. Thank you all, sir. I would thank Professor Akkoli sir and Professor Pramod sir for coordinating this workshop for us. Thank you, sir. This is very essential topic who is preparing for the interviews, and it is difficult when we will do the self-study. But sir has made us easy for us with these pointers in C, and they have explained all the concept with examples and clarified our doubts with each and every topic. They have explained some company interview questions with the solution, and it's very needed for us. The company people will not directly ask, write a program for Armstrong number or a perfect number. They will make a story kind of problem definition. The logic remains same, but we have to go through that. And with these, all the examples, whatever sir has explained, we have to make perfect them. Then only it is very easy for us to crack the exams. And it is a good platform who is in the 7th semester now going for the placement, and they can improve their programming knowledge. And we have got the knowledge about how we have to prepare for the programming in the interview exams, and it is enhanced our knowledge. And finally, I will thank to all, each and everyone who is the part of this workshop. And I request who has attended this workshop, make use of this. And I want to say one quote last. You are the architect of your own destiny. Thank you. Thank you.
Thank you, Sunita.
Thank you, Sunita.
Thank you.
Well said,
Thank
Sunita.
you.
Thank you.
Now I request Nisarga. Are you there? Nisarga. Nisarga. Please.
Hello,
Yeah.
sir.
Yeah, go ahead.
Good afternoon.
Yeah. Be compatible. Be compatible.
Good afternoon, all.
Good
I
afternoon.
Nisarga Magalkot from 6th semester. I want to give feedback about this workshop. As we know, pointer is very basic and most important concept in C language. It was very well explained in this workshop. And this workshop was so efficient and useful in explaining topics in detail. The resource person gave better explanation by giving some examples for each of the topic they explained. We got some assignments that brushed up our knowledge that we got from this workshop. We understood basics of pointers, structures, functions, and arrays. These are the most powerful data structures in C language. In between, they took some session on placement activities and motivated us. The workshop was overall a successful and worthy one. I hope it will help me a lot in future. Thanks for all the panel members to arrange this workshop and giving us wonderful experience. Thank you one and all.
Okay. Thank you, Nisarga. Nisarga.
Thank you.
Nisarga.
Haan, sir.
You tell
sir.
your name and semester.
I, Nisarga Bagalkot from 6th semester.
Okay. Good. Thank you.
Thank you, sir.
Okay. Amog. Amog. Sureka.
Yes, sir.
Please. Sureka.
Good morning to all. Yes, sir.
Yeah. We are listening.
Good morning to all. I am Sureka Hubbadi from 6th semester. I would like to give feedback on pointers in C. First, I thankful to that our ECE department by organizing pointers in C. And the concept is very detailed explained by Navalgun sir, Shrikant Shirkol sir, and Kotresh sir. It's very useful our placement activities, and the pointers in C covers the introduction to C and how to declare pointer, how to initialize, and main thing how to read pointer and pointer, and also pointer in arithmetic, pointer and structure, pointer and function, and the main thing they covered that favorable questions that are asked in asking in that placement activities. So thank you that our HOD sir, Professor Ravi Yadhari sir, and Akkole sir, Pramod Patil sir, organizing such wonderful activity in lockdown period. Thank you so much.
Thank you, Sureka. Amog.
Thank you, sir.
Amog. Anybody interested? Shruti? Shruti, Murgundi? Amog? Anybody interested? Hello? Nikita? So I think, sir, most of them are maybe in the busy with
Yes.
Quiz.
No
quiz.
problem. Okay.
So we thank all the students for their valuable feedback. It is really motivating to us.
Yeah.
Okay. Sir, shall we do one thing? Shall we log out so that people can start with their quiz?
Yeah, no problem.
No, students are taking the quiz, sir, online.
They're taking quiz now. Okay.
Yes, sir.
Sir,
Yes,
I have
sir.
to do the HOTAP, thanks, no?
Oh,
Yes,
yes, sir.
Sir, they can take parallelly, not a matter.
Yes, sir.
They can take the quiz parallelly. So logging into the meet, it's not a problem for them.
So now, what we have to do, sir, now? Shall I conclude or whether
Yes.
we'll make it on?
Sir, we'll conclude, sir. No problem.
We'll conclude, sir.
Okay. So, good afternoon to all.
Afternoon, sir.
Yeah. Principal Dr. S.C. Kamte, sir. Our HOD, Ravi Adai, sir. Dr. Navalun, sir. Srikant, sir. Kotre, sir. And my colleague, Pramod, sir. And dear all participants. So, this was a very nice and first time we did, and that to the online, these 4 days exploring pointers in C. So in this is the online we did first time when we approached Navalagun sir. So he wholeheartedly agreed to extend the services, and our Ravi Adai sir, he motivated us to conduct this for the all pre-final and final year students. Sir, final year students, a few of them have not attended. They have got some placement training. They messaged me also. So, and we focused around 50 students, even though students may be registered, but our college is in some rural area, and I inquired also. Few students got some network problems, sir, and 2 days also some the cloudy situation was there and rain season was there. That is a not problem, but the core students, those who are really interested, they have undergone, sir, this training program very nicely, and these 4 days. Most of the students have interacted user also very good, and they have enhanced their knowledge especially in the pointers, and I am very much thankful to you all, especially for these pointers and the placement questions, sir. You have very nicely explained to the students, and I was also observing students are very eagerly watching this all and listening and asking the questions. So near future, sir, we also conduct such the linked topics like this. So even I got feedback from some industry, that is from our alumni. They told, they also motivated me, sir, conduct such programs like this. Navalgun sir. Yes. So I am very much motivated once again to extend again the services of you. I hope you will extend in near future also. So I thank you all on behalf of our principal, management, HOD sir, and my all colleagues and all the. Thank you, sir. Thank you, Anna.
Thank you, sir. Thank you very much for giving us an opportunity to share the little knowledge with your students. I also thank Dr. Ravi Adali sir and Pramod sir and Principal Dr. Kamte sir. Sir, thank you very much. It was also a new experience for us, where this is the first time where we started training the students through online. Through online. So I hope students are happy with this training, and thank you very much, sir.
Thank you, sir. Thank you.
Thank you, sir. Thank you.
Sir, I take this opportunity to thank all the organizers, sir. Akole sir and Pramod sir were very much active and very much supportive throughout the session. Sometimes, we did not follow the timing. We extended till 1:15, 1:30, and you were, very much enthusiastic. even you were attending so many sessions,
Yes.
and that really motivated, sir. We are very much thankful to you. And I would like to thank Dr. Edeli sir and Dr. Kamte sir for providing this opportunity. And this is our first this kind of online course, sir, that we conducted. Here and there might be some small issues that we faced. In the next session, we will try to improvise further, sir. So thank you, sir. Thank you once again.
Thank you.
Thank you, sir. Thank you.
Sir Akole sir, thank you so much from my end also, because it has been a very nice journey. Pramod sir and you both of were sitting throughout, and
Thank you.
I think
It was a really wonderful session.
Sir.
Sir, Pramod sir is Pramod sir is a lecturer in especially in C and C++.
Oh, great,
yes,
sir.
sir. Actually, I take these subjects, sir. Even I learned so many things.
Oh,
it
great,
was
sir.
really like wonderful sessions we have come up with, and we'll see how the students will get the feedback, and we are going in future also we'll think to organize some sessions like this.
Sure, sir. Sure. Sir, thank you so much once again for all the coordination from Akole sir and Pramod sir. My personal thanks to also Dr. Edel sir, because he has been motivating force for me. Thanks also to Kamte sir for giving us an opportunity. As Professor Shrikant and Kotresh rightly said, we keep on conducting this course in the college live, but this has been our first experience online. And we just want to improvise, and your valuable feedback will definitely help us to go further. Thank you once again, and if there is any requirement, please let us know, sir. In terms of placement, ultimately our thinking is like 4 years. For 4 years students study various courses, but at the end what they require is a kind of a little bit energy booster. Of course, this course of whatever some 12 hours duration, like for the past 4 days or so, is not a replacement for what they study in those 4 years of engineering. It's not a replacement, but we just consume food and then we take some extra protein tablets or some protein powder to get more energetic. So it is that kind of approach where they are fed with a little bit of extra delta input, with the help of which they can get ready at the nick of time and then hit on the head. So the students' performance is going to speak for itself. So I sincerely want to thank each one of you from the bottom of my heart for this opportunity. We will also share, as Shrikant and Kotresh rightly said, the results of test, so that the students can reflect on what they have understood, what they have not understood. And we also encourage each one of them to go through the YouTube channels where all these videos are made available. Today's video will be made available within a short while from now. And we'll take this journey forward, sir. Thank you so much, Pramod sir, once again. Thank you, Akoli sir. You have been fantastic coordinators. Thank you, sir. Thank you.
Thank you, Shrikant sir and Kotresh sir. Thank you for the wonderful
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you. Sir, let it continue, no, sir?
Sir,
yeah, please.
Sir, quiz responses we are recording already, so it's not mandatory that they should be on Meet. They can just leave the meeting, sir. So